Okay, a quick rundown on how to complete the square. And first of all, we want to answer the question why. Why are we completing the square? And the goal of completing the square is to change a quadratic function from y is equal to ax squared plus bx plus c, which is in standard form, which doesn't really tell us much. Tells us the y-intercept, tells us the direction of opening and the step pattern, but not much else. And we want to change that to y is equal to a x minus h squared plus k, which of course is in vertex form. And we like vertex form because it tells us where the vertex is, of course at h and k, and the step pattern, and so we can graph the function. The other thing that this is going to tell us is our optimal value. That is, when I'm graphing the function, it's going to tell me my maximum or my minimum value of the function, so where the vertex is, and this we're going to see a lot more in application type questions. Okay, so when we complete the square, in order to get it into this form, what we need to do is we need to add in some value that's going to give us a perfect square trinomial. Right? So let's just remind ourselves what a perfect square trinomial is. So a perfect square trinomial is one that's in the form of a perfect square at the start, a perfect square at the end, and the middle term is the square root of the first times the square root of the last doubled, so 2ab. Or it can be a perfect square at the start, a perfect square at the end, and minus 2ab. And perfect square trinomials are nice, if you remember, because when we factor them, we just take the square root of the first, square root of the last, and square the whole factor. Or in this case, when there's a minus, square root of the first, square root of the last with a subtract sign in between. So for example, let's say I had x squared plus 10x plus 25. This is a perfect square trinomial because the first terms are perfect square, the last term's a perfect square. And the middle term is 2 times the square root of the last term times the square root of the first. Square root of the 25 is 5, square root of 1 is 1, and 5 times 2 is going to give us this 10. So this would factor into x plus 5 squared. Okay, so that's the key to how we're going to get from standard form to vertex form. All right, so let's take a look at that again. Let me get a new pen here. Okay, so you might be asked the question something like this. Determine the vertex of, and we'll say each quadratic. All right, so let's start with A. So let's say I was given the quadratic function y is equal to x squared plus 6x minus 1. And we need to know what the vertex of this is. So what I'm going to do is I'm going to add a value in right here that completes the square. That is, I'm going to add in a value that's a perfect square trinomial. But I can't add a value in without it changing what the actual graph is going to look like. So I'm going to add a value in and then take it away. So I'm going to add something in and take it away. So really, essentially, all I'm doing is putting in a 0. So that's going to look like this. So I've got x squared plus 6x. And what I want to do is I want to add something in and then take that same something away. And essentially, I'm just adding 0, which isn't changing it. But if I add in something that makes this a perfect square trinomial, I'm just going to change the way the equation looks. It started off like this in standard position, and I want to get it into vertex form. So the value that I'm going to add in is a value that completes the square. And in order to find the value that completes the square, I take the middle term, divide it by 2, and square it. So half of 6 is 3, square that is 9. So I'm going to add 9 and take 9 away. And what that has given me then, right here, these first 3 terms, it's given me a perfect square trinomial. So now on my next step, what I'm going to do is I'm going to factor that perfect square trinomial. And we factor it by taking the square root of the first, the square root of the last, and the middle sign. So x plus 3 squared. Now I'm left with this minus 9 over here and this minus 1. So now we just simplify. Negative 9, take one more away, is negative 10. And now this is a quadratic in the form of vertex form. So now I can read the vertex. The vertex is the negative of this value, the opposite of this value, and then the k value taken at face value. So that means that if I was graphing this function, a little crude graph here, I'm down at negative 3, negative 10, and this function opens up. I also know I have a y-intercept at negative 1. So it's going to look something like this. Okay, in this next example, we're going to have something a little bit different. We're going to have an a value tacked on to our equation. So let's say I have something like 2x squared, as opposed to up here I didn't have an a value. I just had x squared. So let's say we have 2x squared minus 16x, and let's go plus 11. Okay, so remember that our goal is to get it into the form a x minus h squared plus k, because then I can read the vertex off of it. But notice that in this form, the a value is factored out in front of the perfect square trinomial. So when you have an a value here that's not 1, you have a first step before we can add in the perfect square trinomial. And this first step is to factor the a value just out of the first 2 terms. So it's x squared minus 8x. And that plus 11 just gets tacked onto the end. We're going to worry about him later. So now that I've factored out the a value, it just stays in front. The plus 11 just stays at the end until we need it. Those are kind of our bookends. And what we want to focus on is inside the brackets here. And this is where we're going to add a value and take a value away. So I'm going to have x squared minus 8x plus some function, or plus some value minus some value, and then plus 11 at the end. Okay? And now I have to think, what value can I add in here that's going to allow this to be a perfect square trinomial? And in order to do that, I need to take the middle term, this term here, the 8, divide it by 2 and square it, half it and square it. So negative 8 divided by 2 is negative 4. Square that is going to be 16. So I'm going to add in 16, but I have to take 16 away too, so I'm just adding 0. Okay, so next, the 2 just stays in front because we're not playing with them. Now I just want to look at these terms here. This is my perfect square trinomial. Let's factor it. So to factor this perfect square trinomial, I'm going to take the square root of the first, the square root of the last, and the middle sign. So x minus 4 squared. Well, now we're left with this minus 16 here. It was part of the bracket. That is that the 2 was going to multiply that out if that's what we wanted it to do. But we don't want it in our bracket anymore. We want it out of our bracket. So in order to get it out of our bracket, it has to multiply by the a value in front. So it's going to be 2 times negative 16, which is going to give me negative 32, and then I'm going to add 11 to that. Now I just simplify the end here. So I'm going to have 2x minus 4 squared, and then minus 32 plus 11, minus 32 plus 10 is minus 22 plus 11, so it would be minus 21. So therefore, I've got this now in vertex form, so I know that my vertex is going to be the opposite of my h value and then my k value taken as is.